Hello everyone, we're looking at example 6 now, still section C of chapter 24 on page 643. We need to use technology to illustrate and calculate. Okay, the probability that the z-score, notice this is z here, not x. Okay, so we're talking about the z distribution. Probability that z is in between negative 0.41 and 0.67. So let's draw what this looks like. Z distribution is a normal distribution with mean 0, first standard deviation 1, first standard deviation this way, -1, and so on to -2, okay? We need to find the probability in between negative 0.41, so we're actually looking, negative 0.41 isn't quite halfway here, okay, so I'll put that in like this. So we're looking here to 0.67, so 2/3 of the way across to 1, so approximately here. 0.67. So we're actually looking for this area. That's the area we are looking for. So on our calculator, we can do this. We go to our calculator and we say menu, probability, number 5, distributions, also number 5. And we're still looking at normal CDF. Okay, still looking at normal CDF. Okay, it's a normal distribution, and we're looking with a lower bound and an upper bound. Okay, so the lower bound is negative 0.41. The upper bound is 0.67. Now look, automatically in here we had the mean of 0. We can leave it like that. The standard deviation of 1, we can leave it like that. Okay, so if you forget at any point, you can see that that's what automatically fills in, and that's a good reminder for you. Okay, and our answer, look how it should be notated. Normal CDF, lower bound, upper bound, mean, standard deviation in brackets, and your answer. Okay. So we then have normal CDF. This is how we can notate this on our calculator. Lower bound, negative 0.41, comma, upper bound, 0.67, comma, mean 0, comma, standard deviation 1, okay, and that equals 0.408. Okay, so 40% of the data is in between that standard deviation away from the mean and the standard deviation away from the mean. Okay, second one, probability that z is less than or equal to 1.5. Again, let's draw our z distribution. 0, 1, 2, -1, -2. We want to be less than or equal to 1.5. Okay, so always a good idea to draw that distribution so you can be critical about what your answer is and make sure it makes sense for how big it is. So 1.5 is halfway in between here. Halfway in between, okay, 1.5. And anything less than or equal to that. So we're actually looking for this entire area. That entire area. So it's going to be a big number. It's going to be bigger than 50%. And it's going to be bigger than 50 plus 34 more percent. So it's going to be bigger than 84% or 0.84. So being critical of that. So again, go to your calculator, menu, probability, distributions, normal CDF. Lower bound is the negative infinity. So leave in what they have there. It means -9 times 10 to the power of 999. Upper bound, 1.5. Mean 0, standard deviation of 1 because it's a Z distribution. And okay, we get 0.933. So again, normal CDF. Negative infinity, you can write like this to notate it, is the lower bound, 1.5, upper bound, 0 and 1, and that equals 0.933. Did I round properly? Yes. Okay, last one. Again, we have this normal distribution. It's a Z-score, so we know that the mean is 0, and standard deviation is 1, so we can write these values in as well. This time we want bigger than 0.84. So 0.84 is closer to 1 than it is to 0, 0.84. So let's say about there. And anything bigger than that. So we're looking for this area. So we know that's going to be less than 50%, just being critical about it. And we go to our calculator, menu, probability, distribution, normal CDF. Lower bound is now this. So this is why it's helpful to draw the diagram. You don't get mixed up which was your lower bound and which is your upper. Lower bound is a 0.84. Upper bound is positive infinity. So we say 9 times 10 to the power of 999. Mean 0, standard deviation 1, and we get 0.200. So normal CDF. Lower bound 0.84. Upper bound infinity 0 and 1 equals 0.200. Check our answers with the textbook, and they are all correct. There we have it. Have fun.